Students and independent learners looking to use this to prepare for their Site Surveying and Levelling Camp Assessment, SSL TO2, will find worked examples by following the links in the description below. You can use the PSION Organiser Emulator to practice using the organiser ready for your field assessment work. Set the Organiser Emulator to an LZ64 and select it. You will then need to upload, create a LandPack OPK, give it a name, create it in the emulator and insert it in slot B. Before starting using Land, I suggest you set the time. You could use set clock in the emulator, but in the field you'll need to use the time function on the menu. Practice using that. Press mode to get the menu. Press set to get the to be able to set the time, and use the arrow keys to navigate around the screen to set it to the values that you want. Press execute when you're happy with the time displayed. For this demonstration video, I'm going to use the documentation for the site booking sheets for project PA257. You'll find access to those by following the links in the description below. If you're starting a new project, you'll have to give you'll enter Land, you'll go to Leveller, Travis is in another video, and you'll need to create a file, and then you'll be asked to enter the starting bearing. For our project it'll be 10 meters. Before we can go ahead and enter data, we need to understand how to format the data ready for transfer between the Travis part and the Leveller part of the land surveying software. The operating tips will show you the examples, but basically you need to give the stations the name STN and then the station name. That way the software can pick in the values it requires. I've entered most of the data into this Leveller program to save time in this video. So I'll give it the file name that I gave it, PA257, and it'll ask me to confirm that I'm operating on an existing file. Yes, I am. I'm going to use View to view the data that I've entered so far, and I'm going to use the arrow keys for navigating around that data. First booking was a TBM, and it started with at 10 meters reduced level. The data that I've entered I've put into this spreadsheet on the right hand side here. The greyed out data is the data that I've entered. You'll see when I get to booking number 5, the soffit, there's a slight bug in the software that it can't actually display the minus sign of the inverse staff reading. Don't let that worry you if you see that in the field. The data is actually safe and is stored correctly. It's now time to continue with the data. I'm going to enter the highlighted data. The first backsite, 1.5, is to the known change point, 8.915 reduced level. That's already in the system. But that allows it to set a new height plane collimation, HPC. The next reading is an intermediate site, station J, and that should give me a reduced level of 7.602, which it does. So I know the software is working. Obviously you won't have this spreadsheet when you're in the field. 3.161 is the next intermediate site, and that's for station K. STN K, that's going to be transferred into the Travis program for point K. That's why we're using that STN space letter format. Station L will give me an 8.106. And finally, the last foresight, obviously we always end with a foresight, 1.506, I've returned a value back to D. I've cited D just before I've finished. I've done this just so that I can check my accuracy. You'll see on the spreadsheet, 9.345 was the first time I read D, and the second time I read D, 3.59. It's 4 millimeters difference. That's within the acceptable misclosure of 8 millimeters, so I'm happy with the details. I could view these again, but I don't need to. What I want to do now is I want to print these details, and then in a second I want to transfer these details into the Traverse program so I can calculate the planned distances. So I'm going to use Sci2Win. I'm going to put it into print mode, and I'll send the data. When the data is sent across, it'll ask me for a file name because I'm using a PDF writer and I'm creating a PDF document with the details in. PA257 level, to distinguish it from another file I'll do later, which will be the Traverse file. Before I print the Traverse file, I'll come out of the leveler section, as the details on the screen are telling me, and I'll go into Traverse, and I'll enter the file name for the Traverse file, which again was PA257. The operating tips will explain how you can keep using the same file name for different files. I'm going to select Reduce Level because I want to take the reduce levels from that leveler file and put them into the Traverse file. So I'll use File Transfer, and it will ask me for the name of the file in which I want to transfer the files, PA257. That will be your initials and your class register list number. It transfers the files and then it automatically calculates the planned distances. That's what we wanted. I can't go much further in the plotting out without the actual planned distances. The slope distances are no good to me. So now all the data is in the machine. All the angles, the reduced levels, the coordinates, everything's in the machine. Everything's been calculated. One final thing I need to do is I need to print it out. So we'll take the print from the Traverse section. And again, I'll use Sci2Win. And I'll put Sci2Win again in print mode, and I'll send the file. When the file's gone, again it will save it as a PDF because I've got it going into a PDF writer. I'll give it the name PA257, but this time it's the Traverse data, so I'll call it PA257 Traverse and save that. So when I return to the main menu, that's everything done now in the organizer. I can turn it off, quit and turn it off. And now I've got all the data printed, so I can go into my CAD program and now I can draw up the final plot. I'll finish with that, have fun, and you'll see that on the final plot there's an unacceptable misclosure error. That northing error of 596 millimeters is not really acceptable. You might get away with it on your project, but really it needs to be tightened.